Hi, I'm Randall Heyman, a university academic. Because of the coronavirus outbreak, I'm using my YouTube channel to make quick turnaround videos of mathematical problems and concepts that students are having trouble with. So if you're a lecturer, tutor, high school or primary school teacher, parent, grandparent or student, and you'd like me to make a video for you or your students, use the comment section below the video, or you can drop me an email at coronahelpmathematics@gmail.com. So someone in America, actually from California, I'm getting a lot from California. Surely there are other states in the US. Anyway, they've asked me about things like maximal ideals and prime ideals. So, well, I thought I'd start off by just calling up the Wikipedia page. And the important point here is, I think, is that you can see here there's a lot of different ideals: maximal, minimal, prime, radical, primary, principal ideal, blah, 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 all the way down to fractional and invertible ideals. So you don't want to try and learn them all in one go. In fact, you'll only really get, for most people, you'll only really get comfortable with them by using them to solve some problems and understand some more concepts that involve a particular ideal. So I'm not suggesting that you should try and just learn them all off by memory or anything like that. Notice also, I don't think you can see my cursor when I've got it like this. But if you look through it, you'll see quite a bit. It talks about left and right modules, ideals, and well, it might say left and right ideals. I'm not sure. Actually, having said that, I don't think it does. Okay, anyway, we discussed left and right ideals in one of the other videos. Okay, so let's go up here and go to my whiteboard. Okay, so some important ideals. Okay. So the first one that we need to do is improper, an improper ideal. Why don't I try some capitals? An improper ideal. I is an improper ideal if, no, actually, let me set it up. I'm going to use I and R of R if I equals R. So a ring is actually itself an ideal in the ring. Example, let's let R, the standard, I think the standard examples I'm going to use here are the integers. That's the classic example of a ring. And so Z is an improper ideal in R. The examples I'm going to give you are all very standard, involving the integers. Nice little exercise though, if you might like to have a think, if you're searching through the internet and any books that you have and lecture notes, whatever, if you find any good examples, slightly more complicated examples of these sort of ideals, please comment me or drop me an email, and if I get a few of them, maybe I'll do a video just with some sort of more interesting examples of particular ideals. Okay, trivial ideal. Trivial. Let's call it I. This time we're just going to, it's the set consisting of just the 0 is the trivial ideal of R. Okay, so there are these two sort of funny ideals, the improper ideal and the trivial ideal. Maximal ideal I, in this case, we say that it's got to be proper, can't be improper. So it can't equal, the ideal cannot actually equal the ring, is a maximal ideal if, let me just write it out and then I'll explain it. Okay, so the first thing I want to point out is this symbol here is subset, but it's a subset without the equals. So it can't equal, it can't equal, you know, both sets can't be equal. Now I think in some European places, let me just stay in with red, that is what we would say is this. So I'm sorry about that. In fact, what I could do, just to make it clear, this is the way to make it clear, is you go like this, not equal. So C, I is a subset but not equal to N, which is a subset or not equal to R for some ideal N. So what we're saying is between I and R, there has to be another ideal. So example, 6Z is not, it's not a maximal ideal. Why is that? Well, we could draw Z's here, 6Z is here, but between them is either 2Z or 3Z. You can write whichever one you want. So in this case here, sorry, that's not very good. So in this case, between 6Z and Z, there is another ideal, in this case that I've drawn here, 2Z, or if you like, you know what I mean? Since 6Z is a subset but does not equal to 2Z, which is a subset and not equal to Z. So 6Z is not a maximal ideal. Let me just write out, this is from previously. Okay, but 7Z is a maximal ideal. There is no N, I'll just not equal to Z, such that 7Z is a subset but not equal to N, is a subset but not equal to Z. Or in the language of the Venn diagrams, if we have 7Z here, and here we have Z, well, there's nothing you can draw in between. There's nothing you can draw here, another set between them. Of course, 14Z is, you might say 14Z, but 14Z's in here somewhere, a little one here. It's a subset of 7Z, so that doesn't help us. Okay, so that's maximal ideal. Okay, we're back on black now. Prime ideal. Prime ideal. So I not equal to R, so it can't be a improper ideal. It is a prime ideal if, what's the best way to put this? If A, B, what are we saying here? AB is an element of I implies that A is an element of I or B is an element of I. So this is a little bit, this is like the prime numbers, the primes in the integers. Look, generally what we do is in school level, we say, well, 6 is not a prime because 6 equals 2 times 3. As you get on more in mathematics, this argument, and 7 does not equal A times B, where A and B are not equal to 1. So this idea here is really not primality, it's really irreducibility. So we would say that 7 is not, or is irreducible. That's the proper thing to say. But in the case of the integers, it's the same as saying that 7 is prime. 7 is irreducible. Really, what the primality concept would say that 7 is prime because if A times B equals 7, then A equals 7 or B equals 7. Okay, so that's just a by the way, little diversion. So what's an example? Well, 6, I don't think 6, 7 is not a prime ideal. Why is that? Well, 2 times 3 is an element of 6Z, but 2 is not an element of 6Z, and 2 is not an element of, 3 is not an element. 6Z. Okay, so I think we've gone through the basic ideals. As I said before, if you've got any interesting ideals, please comment to me or email me with them. And if I get a few of them, I might do a video on it. It'd be interesting to see what you can come up with. But just in terms of anything to do with mathematics, please feel free to comment below any of my videos, or you can email me at coronahelpmathematics@gmail.com.